You're sitting on a high-speed train 250 km per hour, 78 m below the ocean floor. That's deep as 25-story building. Above you, cargo ships crossing one of world's busiest shipping lanes. Water pressure at this depth could crush car like tin can, and you're casually scrolling phone, completely unbothered. This isn't science fiction. This is happening right now in China. The Jintang Undersea Tunnel, over 16 kilometers long, more than 11 kilometers, carved directly beneath seabed. Two massive tunnel boring machines size of apartment buildings meeting deep underground with precision of surgeon's scalpel. How do you drill two tunnels from opposite sides and make them meet within centimeters? What is the Jintang Tunnel? Jintang Undersea Tunnel, centerpiece of Ningbo-Zhoushan rail link. The record 16.18 kilometers total length. Undersea portion exceeds 11 kilometers. One of longest undersea rail tunnels ever built for high-speed trains. What makes it special technically? High-speed rail undersea 250 km/h, not slow commuter trains. Bullet trains, large diameter nearly 14.5 m, supports twin tracks plus systems. Here's what people miss. Crazy part isn't length. It's what's underground and what's changing every few hundred meters. Why build under the sea? Zhoushan Island region. Historically, no rail connection. Current trip bridges, ferries, cars, slow, indirect, weather dependent, congestion risk. Why not just build another bridge? Shipping lane constraints. Massive vessels. 100,000-ton cargo ships passing constantly. Bridges need tall spans. Surface disruption. Vulnerable to typhoons. Tunnels avoid ship traffic completely. Weather irrelevant direct route. The payoff: 30 minutes Ningbo is ocean instead of 1.5 hours by car. Economic zones connected seamlessly. Tourism boosted. Cargo efficiency improved. So if tunnel is answer, what kind of machine can even drill this? Meet the machines. Two slurry TBMs, Yonghu and Dinghai. Scale comparison, roughly 4,350 tons each. 8 fully loaded Boeing 747s. Cut-ahead diameter 14.515 m, size of 5-story building. What slurry shield technology? Pressurized face balances seawater and ground pressure. Keeps water out. Spoil carried away through slurry system. Separated at surface. Recirculated. Think industrial washing machine. But for rock and dirt. How tunnel built while digging. Precast concrete music segment rings installed immediately behind cut ahead. Sealed and bolted into watertight tube. Like stacking giant Lego rings. Immediate grouting fills gaps. Locks ring into place. Becomes permanent structure. The two teams set up. One TBM digs roughly 5,000 m from Ningbo side. Other digs over 6,000 m from side. Meeting undersea. Precision required. Millim, but seabed isn't uniforms. What happens when ground changes 28 times? The technical villain. Mixed geology. The threat. 28 transitions between soft ground and hard rock. Why transitions are dangerous. Different resistance on each side of cut ahead. TBM wants to drift, tilt. Soft ground can deform, flow like mud, rock is abrasive, eats cutters. 1 minute drilling through granite. Hard, stable, predictable. Next minute hitting soft clay, sandy soil, can shift, collapse. Engineering responses. Smart monitoring. 20,000 sensors throughout TBM. Algorithms tuning torque and music thrust in real time every few meters. Different additives on different sides of cut ahead. Equalizes conditions. Water injection systems deal with sticky clay. Prevents clogging. Reinforced sealing systems withstand crushing water pressure at 78 meters depth. Segment lining plus grout sequence becomes stabilizing backbone. The stake small drift early becomes huge miss later. In this environment, Precision isn't luxury. It's survival. So how do you steer for 1,000-ton machine 6 kilometers undersea to meet another one? The millimeter game. Catastrophic failure scenario. If they miss by meters, 2 useless holes, billions wasted. The metaphor threading needle except needle 15 m wide. Buried 78 m deep. Guided from 6 kilometers away. Compounding error problem. Tiny angle error at start equals dozens of meters off target. 1 degree deviation at starting point, dozens of meters wrong by middle. An underwater can't exactly stop and measure with tape measure. The solution? BU satellite positioning. China's answer to GPS network of navigation satellites, but traditional satellite positioning off by few meters completely useless for this. Chinese engineers took it further. Satellites linked directly to auto navigation systems on both TBM systems constantly track machine positions in 3D space, latitude, longitude, depth, real-time kinematic positioning, art correction, concept base station, send correction data, achieve centimeter level positioning accuracy. The feedback loop every few meters. Position check. Compare to planned route. Micro-adjust cutter head angle. If drifting centimeter off-course, system adjusts immediately, brings machine back in line like GPS, accurate to 2 centimeters, guiding 4,000-ton machine through solid rock. The result when Dinghai and Yongxiao finally met deep under seabed. Alignment error less than 20 millimeters, less than 2 centimeters on tunnel over 11 kilometers long. Threading needle from across football field 2 centimeters. But now what? Machines met. They can't just drive out other side. Shedding the shell. The problem: undersea TBMs effectively trapped. No easy extraction. The solution? Dismantle from inside. Remove valuable components. Leave shell. The ritual. Shedding the shell. Drive systems removed. Cutter heads extracted. Hydraulic components recovered. All expensive reusable parts hauled back through tunnel like gutting building from inside until only skeleton remains. The clever part: outer steel casing stays in place forever. Becomes permanent part of tunnel structure. Reinforces walls. Provides extra support. Poetic engineering. Machines don't just build tunnel. They become tunnel. Complete their mission. Then sacrifice themselves. Ensure tunnel lasts decades. Most practical solution: extracting them more expensive than building new ones for next project. So if this possible here, what does it unlock next? What it means. Context: built as part of broader high-speed rail expansion. Final boss level. Why Gent matters technically. Proof that long undersea Hesse tunnels can be done with. Variable geology adaptation. 28 transitions handled successfully. Centimeter grade navigation. 20 MB precision achieved under TBM. End-of-life strategy: shedding shell works. This is benchmark template proof point. China's high-speed rail 45,000 kilometers more than rest of world combined. Mastered bridges, viaducts, mountain tunnels. Ocean was final boss. They beat music at the unspoken implication. Taiwan Strait 130 kilometers wide at narrowest point, 8 times longer than Jintang Tunnel. Water deeper. Current stronger. Geological conditions more complex. Most ambitious tunnel project in human history. If attempted, but if you're going to attempt something that insane, you practice first, build smaller versions, test technology, refine techniques. That's exactly what Jintang Tunnel is. Proof of concept. China saying we can build high-speed rail tunnel under ocean at depths that would crush most structures with precision measured in centime, faster and cheaper than anyone else. Whether Taiwan Huan Strait Tunnel gets built, different conversation, politics, economics, but from purely engineering standpoint, China just proved it's possible. Developed machines, navigation systems, music, construction techniques. Expertise that's big deal for decades. Underwater tunnels. Considered final frontiers of civil engineering. Expensive, dangerous, technically brutal. Most countries built 1 or 2 in entire history, cranking them out like weekend project. Hong Kong Shuhai Macau Bridge nearly 7 kilometers underwater tunnel section completed 2018. Jintang Tunnel done 2028. Plans for more already exist. Not just building infrastructure. Building playbook for how to do impossible. Construction began late 2020. Tunneling ramped mid-2024. Target excavation music completion end 2026. After that year of finishing work, track laying, electrical systems, safety equipment, ventilation, lighting. Opening 2028. Passengers travel Ningbo to Zhaoan in 30 minutes. Air-conditioned comfort 250 km sh 78 m below ocean. Summary with one liner: 2 machines 11 km under sea, 2 cm precision. This changes what's possible. What people think can be done. 50 years ago, high-speed train 78 m below ocean. Pure fantasy. 20 years ago, theoretically possible. Economically insane. Today, China doing it. Planning next one before this one finished. When one country demonstrates something can be done efficiently, other countries pay attention. Projects considered too risky get reconsidered. Experimental techniques become standard practice. Entire field of engineering takes leap forward. Jintang Undersea Tunnel isn't just impressive project. It's paradigm shift. Blueprint for connecting islands, crossing straits, linking continents. Future of transportation may not be in sky, may be under waves. If this deep dive into most insane engineering project changed your perspective, smash that like button. Subscribe for more mega project breakdowns. Comment question: what's more impressive, the 28 geology transitions or the 2 cm meetup? Drop your answer below. Let's discuss. Thanks for watching. See you in next one.